In this video tutorial, I'm going to introduce you to the Sleuth Kit, or TSK, and Autopsy. The Sleuth Kit is a collection of command line based tools which can be used for forensic analysis of a disk image. However, being that they are solely command line based, and for someone who's new to this field, they can be rather solely use the command line, we instead use Autopsy. Autopsy is basically just a front-end GUI for the Sleuth Kit, and which basically transforms many of the tools into the Sleuth Kit into a web browser-based experience where you can analyze a disk simply in a point-and-click environment through your web browser. Today what we'll be doing is I'll show you how to build a new case in Autopsy, and then we're going to analyze two disk images. The first one, which I have placed on my desktop, I've placed both of them on my desktop, is what I named the deleted travel drive. Essentially, I took a very small USB drive, I formatted it, and then I put three files onto it: a text file, a JPEG image file, and a docx file. I then went ahead and deleted those files. What our goal today is going to be is basically to use Autopsy to recover those deleted files. The second example here is called timeline analysis, and what we're going to use for that, what we're going to do with that one is we're going to use Autopsy to sort of look at a timeline of what happened on this drive. You can use Autopsy to sort of create a timeline of activity, which will show you when files were created, when they were deleted, maybe they were moved to the recycle bin, anything like that. So we're going to use this example to look at that. So the first thing we're going to do, and just for reference, more information on the Sleuth Kit and Autopsy and copies of these two images can be found throughout the rest of this module. The images are in the resources section. More information on everything is also in the resources and in the slides. So for those interested, you can follow along or go through some of these as the challenges. So we're now going to start Autopsy. To do that, we will go into the analysis tools. I'm using the Cert Fedora box to do this because it has Autopsy pre-installed. I'm going to open Autopsy, and you'll see it'll open in Firefox in a very easy point-and-click environment, and hopefully it'll open soon because we're now going to wait for it. There it goes. So as you can see, it's a pretty simple window here. Just so you know, if you hadn't started Autopsy from the icon on the desktop, or if you'd been using a different Linux-based machine, and you had started Autopsy from the command line, you would have to type this into your URL bar to start Autopsy, as it does work in a web browser. So what we're going to do to set up a case, say we were doing a criminal investigation and we're using Autopsy to look at a criminal's hard drive, for example, or in this case a USB drive, we'll click the new case and we'll give it a name. So let's just we'll call it demo, because hey, that's what this is. It can only be one word. We'll hit new case. We're now going to do is add a host. So what the host is basically the machine that we have an image of. So if we were to say arrest a criminal and we were to take a USB drive off of him, the host would be the USB drive. So let's call it USB drive. We won't give a description or anything. We'll leave everything else as is. We'll add the host. Now that we've given the host a name, we actually have to add the image that the host contains. So we gave it a name, but we don't actually have the actual data content from that host. So we're going to add an image. The image we're going to use is that example one on the desktop, and like I said, this is basically a DD image. DD was discussed in a previous module. It's a DD copy, byte by byte copy of a USB drive that I put three files on and deleted three files from. And we're going to use that for our example. So we're going to add an image file, and you'll have to give it the full path. And yeah, you can see that I've sort of tested this out a few times before. And so now that we've given it the path, this is actually an entire disk image. It's not a partition image. Partition image would be, say, if we had only copied the C drive or the D drive corresponding, the Windows correspondent. However, this is a USB drive that I basically copied from start to finish. So it got the partition and then any other USB specific information or anything like that. Now that we've specified that, we can hit next. It's going to give us some options about we can make a hash of it and everything. We're going to skip all that. What we will notice before we go on is that by pointing it to our image, we already see that one of these sleuthkit tools, MMLS, has already given us some information. It's found the DOS partition table on the disk or on the image, which sort of specifies all the partitions on the image. And you can see we have one partition, which is a FAT16 partition. It is a flash drive, so FAT is the likely file system on the partition. And so you see we already have some information about it. We're now going to hit add to add that image, and it was added. So we're going to hit OK. Now that we're here, we can analyze the actual drive, and of course we're trying to recover those deleted files. We could either analyze the entire disk as a whole, or we can analyze the partition itself, which is just the C drive. Analyzing the disk as a whole would basically be one level lower than analyzing the file system on the C drive. We'd be looking at the raw data that just makes up the entire drive. If we just analyze the C partition, we're looking at the file system on the C drive. So we can base our recovery off the information in the file system. So we're going to analyze the C drive. We'll hit analyze, and we're going to do a file analysis. What a file analysis is going to do is basically give us a listing of all the files on the drive. It does this because it's a FAT file system. It looks at the directory entries, and basically there's a directory entry for every file on the drive, and pretty much a lot of other things on the drive as well. So we can go through a list of all the files on the drive. You'll see some file system information like the FAT table here, and MBR, which is also file system information. And then if you go down, you can see in red we have 3 files, which I named findthis1.txt, 2, and 3. And again, like I said before, I had put 3 files on, a text, a docx, and a JPEG, and I deleted them. So you can see that clearly there are still entries for them in the directory table here. The reason for that is because although files are deleted, in many cases the metadata, which is the information about the files, such as the file name or the file size, that information still remains, and it can be used to actually find the file contents on the disk. So as you're seeing here, although that space is now unallocated, in that it's available for reuse, the data still remains in those locations until it's actually overwritten with new data. So if we look at findthis1.txt, we can actually see the contents of the file, and it does say in zip archive. That was for a different example. This is just a text file, and this is the contents of the text file. So you see we've basically completely recovered the contents of our text file, and you see Autopsy is telling us that we're doing deleted file recovery. We could also find out information about the docx. Since it's a docx file, it's a complicated file format, so we won't understand anything, but it is all there. And the cool thing is here we can actually see the full-size image of the JPEG that I had deleted from the USB drive. It's basically just a screenshot I took while making some of these tutorials, but it is an image that I put on there. Before we finish this section, I want to just show one more thing. I was talking before about the metadata. So the metadata is the information that describes each file. So you see for findthis1.txt, its metadata entry, see meta here, its metadata entry is directory entry 7. So directory entry 7, if we click here, we look at directory entry 7 in the directory entry table on the disk, and we can find all the information about this file, findthis1.txt. Written, access, created times, the size, and then the status of the file of these locations, the status of this directory entry for this file, which says that it's not allocated because, again, we did delete it, so it's available for reuse, but until this space is actually needed, the data still remains there, although to the computer, the file system knows that that space is available. We can also see on the bottom the actual sectors on the disk where this data is stored, where the contents of the file are stored, and if we click, for example, on 732, we can see that this is the first block and the only block in this file, and this is file 1 in zip archive. That's all I wanted to show you for this example, but you can see that it's clearly pretty simple in this case to recover deleted files. There are many more things you can do with Autopsy, which we won't get into here, but this is hopefully a good introduction for this. We're now going to move on to the second example where I said we were going to build a timeline of activity on the drive. And instead of building an entirely new case, what we're going to do is, to save time, I made the case beforehand. And I basically went through the same steps, but I'm just going to open the pre-made case, although it would be the exact same steps with creating a new case if you wanted to do this on your own. So example 2 test, and that is the host I want. Again, you see that we can now look at the disk, analyze the disk or analyze the C drive, and you can see that this is the image that was on my desktop. You can see that it does have a different file system type. This is an NTFS file system as opposed to FAT. We're not going to get into the differences, but NTFS is a newer file system with some improvements, a lot of improvements really. You can research that on your own. To create our timeline, instead of analyzing the image, we're going to click on File Activity Timeline. This is a two-step process where in the end we're going to create the timeline, but first we have to put together the data that we want to give, that we want the timeline to be created of. So we want the timeline to be created of basically everything that went on this drive. So we're going to we're going to click Create Data File, and for the data file we're going to provide Autopsy with the entire C partition, because that's what we want the activity of, both the allocated and the unallocated files. And this should create a data file to be used for the timeline. Because I have already gone through this a couple of times, apparently my output file already exists, so normally it would just make it, but we're going to replace it so that it'll be the new one. We'll now sort the data into a timeline, and this gives information about if you want to only get a timeline for certain dates or anything like that. Since we're going to just get one for the entire drive, so we can leave the defaults. Again, my output file already exists, so we're going to replace it. Yours wouldn't exist because you haven't gone through this. Since I ran through this a couple times already, those files already exist. So you can see that the timeline was created and it was saved to var, morg, etc. example 2 dummy output timeline.txt. So I do recommend, as Autopsy does, that you look at the timeline in the text editor. You can view it here, and we'll see that in a minute, but to actually view the timeline, it's much easier to look at a text editor. So what we're going to do is I'm going to open it in a terminal here, and I'm going to, because I'm going to try to make it easier to view the whole thing line by line. It may not work, but let's move to that location. And then we will print out timeline.txt. And yeah, it's still not going to fit in the line. I hope you can still see this when I make it incredibly small, but it should make this easier to sort of follow a little bit. Okay, so it is small, so you may have to go through this on your own, but again, I did provide you with the files. But you can see that some activity took place in 2008 on this drive. We're going to skip all that, but you can see that March 18th, 2012, you have some stuff going on this drive. If we keep sort of flipping through the timeline, going downwards, we will see that after all that file system information happened before, you can see that on March 18th, you have the creation of pic1.jpg and pic2.jpg. So clearly there were two pictures put onto this drive. Following that, you see a lot of information which is preceded by recycler. Recycler specifies the recycle bin, so there was some recycle bin activity on this drive also during these times and dates. We see that a PNG file was apparently deleted from the recycle bin. When it has it deleted over here, it means it was removed from the recycle bin. So we have a PNG file deleted from the recycle bin here, and down here we have a JPEG file which is moved to the recycle bin. It doesn't have it deleted after it, so it just moved to the recycle bin. So again, this is just a timeline of things that happened on the drive. So you can use this to sort of see files created, files deleted, files moved to the recycle bin. Once we know that we have some pictures on this drive and we have some recycle bin activity, we can now use the same techniques we used in the first example to maybe recover some of this data. So let's get out of this, And let me just show you the timeline in Autopsy. Here is the timeline view in Autopsy. If we go to a summary, March 2012, you can see the same thing we saw where you have something going on with a lot of the file system information. And then all the way down here, you have the pick 1 and pick 2 being created. And then, like I said, you have the recycle bin activity. However, I think it's easier to view this in the terminal, so that's why we did it over there. You can view it here as well. Now that we've done that though, so we have this timeline, so now let's actually try to recover the information that we've discovered here. So let's go back to our C drive here, and this time let's analyze it. We're going to do the same thing we did in the first example. Since this is an NTFS file system, not a FAT, some of the file system specific files will be different. You won't see a FAT table. Instead, you'll see things like the bitmap and the log file here. That's specific to NTFS. We can now go, however, and if we scroll down, we see that we do have pick1.jpg, which is a full JPEG image down here. That was not deleted, remember, that was just created. And it won't let me scroll for some reason. There it goes. But you see you have a full image there, and you have another picture here, hopefully. I don't know what just happened to this. Yeah, there we go. I don't know why it's so slow. But here again, you have another picture. Now remember, we also saw that we had some activity in the recycle bin. So let's look in there. Let's scroll down to see what else is going on in the recycle bin. And we'll see that we have this directory. Let's go into the directory, and we can see that here again we have items in red, which means that they were deleted. In this case, it means that de4.png was removed from the recycle bin. And again, it's an image hacker inside. And finally, we also remember we had a file that was in the recycle bin, not deleted. And if we click on that one, that's a JPEG. And again, give it a minute. We can now see the file that was in the recycle bin when this image was made. That's pretty much all I have for now. As you can see, Autopsy can do some incredible things. There's a lot more you can do with Autopsy. You'll notice that a lot of these buttons we didn't even start looking at. And there's plenty more. The Sleuth Kit adds another incredible amount of features. There's a lot of things you can do with the Sleuth Kit that you can't do with Autopsy. There's only so much you can do with a web browser GUI environment. But it's a good introduction, and if you're interested in these tools, you should definitely go ahead and start playing around with them on your own. So I hope this was helpful, and thanks for listening. That's pretty much it, all that I have for now. So have a good night, or whatever, good day.